So hello and welcome. My name is Morgan. We're also joined by Sugu for answering questions. We're both maintainers of Vitess. Sugu, as well as the co-creator of Vitess and founder of PlanetScale. PlanetScale provides commercial services for Vitess. So today's talk is an intro session on Vitess. So let's start with an intro. Vitess is a cloud-native, massively scalable database. To your applications, it looks like it's MySQL. And actually, under the hood, it is MySQL. So Vitess orchestrates MySQL, makes it highly available, makes it scale horizontally by adding new servers. This is a feature that's obviously not available in standard MySQL. And really allows you to operate it in a cloud-native way. And it's released as open source. It's a CNCF project. So just some quick stats about it. Vitess was started at 2010 at YouTube. I believe it went to production in 2011. And now, fast forward to 2018 and beyond, it's a CNCF project. And it's a top-level graduated project with over 200 contributors, 10,000 stars on GitHub. And the current version is Vitess version 7. Or at least current version by the time that you see this video. We are planning to release it later today. There's 18,000 commits behind Vitess, and the best way to be able to get support for Vitess is by going to the Slack channel. And Slack itself is a user and contributor to Vitess, which we will get to on my next slide. So it started at YouTube. I mentioned that fact, but now Vitess is used in many places. It's used by Slack. It's used by JD.com. JD operates the largest Vitess cluster that we know about, which is thousands of tablets. We'll get to that terminology in a second, but a tablet is the basic unit of storage within Vitess. Square Cash App, Pinterest, HubSpot, many of these names you're already familiar with. I'm sure for developers, you're familiar with GitHub, but there are several others as well. I think one interesting thing to point out while we're on this slide is that the adopters are also maintainers and contributors. So if we highlight on this slide, the companies that are employing active maintainers, Slack, Pinterest, HubSpot, Nozzle, Square, we value a lot from their contributions. So I think, I come from a database background. There's a difference between, when a product is created by a product company and when it's really embraced and contributed to by an active team that has to solve real world problems. So, I think we very much benefit in terms of making sure that the right metrics are monitored. There's the visibility into the operating of a system, and the right bugs are fixed. So, we thank these companies very much for their adoption and for their leadership in maintaining Vitess. So I'm going to flick back to this slide quite a bit because I think it explains a lot about Vitess. Vitess is a distributed system, so it's got more moving pieces than a regular MySQL. And there's some terminology to learn to really benefit in understanding Vitess. And we'll use this terminology when we get to really the meat of this talk, which is to explain how we would migrate from MySQL. So on the left-hand side, we can see here's your application. And your application optionally, but typically in a cloud-native architecture, it will route through a load balancer to connect to a VTGate server. VTGate is a component of Vitess. So you can think of it as like a proxy. It's a little bit more sophisticated than that. A proxy/router that will act like it's a MySQL server, but it can retrieve the data from multiple MySQL servers under the hood to be able to scatter, gather, or repiece together the data from multiple shards or segments of your data to be able to return queries to your application. So a VTGate server speaks the MySQL protocol. You speak to VTGate like it's a MySQL server with a MySQL connector, and you can keep using the same connectors in your application that you're already using. And then it routes that query underneath to a set of shards, which are going to be using MySQL. So the shards here, they're comprised of tablets. This is the basic unit of data that we have in Vitess. And a tablet has a MySQL server. You can use MySQL as made by the MySQL team at Oracle. You can use MariaDB. You can use Percona server. In a different mode of operation, which we'll get to as well, you could even use Amazon RDS or Aurora if that's what you would like to use. And the shards store the underlying data in these partitions or segments of data that Vitess recommends you keep fairly small, about 250 gigabytes in size, so that it's easy to be able to scale and add capacity as you need to. So the state is stored in these shards. Vitess can manage those servers to make sure that you've got replicas and you've got high availability. And if one fails, it can kind of make another one step up and take over that. The other information to point out in this slide here is that there's some metadata that is used to route to the current shard for each piece of data, and this is stored in something we call a topo server, or topology server. This is a abstract concept. There's no technology called a topo server. You get to basically take your pick of if you want to use etcd. That's the most common these days in cloud native architectures, but Console and Zookeeper are also supported. And the only other piece that I haven't described on this slide is that there's a management GUI called vtexplain, which can make those changes to the topology for you on your behalf, but it's not an active part of serving. So a lot of detail on this slide, and as I said, I will flip back to it as we're describing various concepts, but for now I want to summarize it as vtgate is the MySQL proxy that routes into your tablets, which is where you're storing your data. And there is a bit of terminology to learn to really understand Vitess. Okay, so next slide. vtgate, we mentioned, is the stateless proxy. A point that I want to stress that maybe I didn't quite on the last slide is that even though your system is distributed, vtgate does present it like it's a single MySQL server, like what you're used to. So your data might be split up on multiple MySQL servers. A table might actually exist in 10 different shards. You will see it like it's one table, and it'll basically just retrieve that data as it needs to. It speaks the MySQL protocol. It speaks most of the MySQL dialect. We'll get a little bit into the details when we talk about our migration, but your keyspaces, a new term to introduce here, which is like a Vitess database, they can be either sharded or unsharded. When you operate in unsharded mode, basically almost everything is supported in terms of SQL syntax. If you operate in a sharded mode, there are some additional restrictions on which SQL is supported. Okay, keyspaces and shards. Keyspace is, it's kind of like what MySQL calls a schema or a database. To use that term would be a little bit ambiguous though, because how the data is actually stored in MySQL is if it's sharded, every server would have a database. Vitess uses this abstract term that makes it a little bit easier to understand, but it's like a logical grouping of tables. And tables are stored in shards. Shards contain replicas or multiple tablets. One of them will be a primary, and then there'll be typically replicas and RD-only instances of shards. We typically recommend that you run with at least 3 copies of each shard, just to make sure that you have high availability. When you're choosing your sharding scheme and your sharding design, I did throw out that Vitess likes to aim for coming from a database background, what I would say is fairly small shards at 250 gigabytes a piece. I know from my experience of operating MySQL that it's, with a well-optimized system, fairly possible to have terabyte-sized database instances. But the reason why Vitess recommends this is it's very easy to be able to do a failover. So typically if a shard fails or a server fails, you want to be able to recover that within about 10 or 15 minutes just by restoring the data to somewhere else on your network. And if you aim for about this 250 gigabyte size, that seems to be about right to make sure that you can achieve that. If you pick a larger size, then you run into risks like while you're doing recovery, you could have a follow-on failure. It's not an actual restriction that Vitess places to be able to do that. Another thing for operating, a large-scale system is that you want to make sure that no user can kind of impact the other users too much. So you do get some natural fencing or basically a boundary on blast radius if you do pick smaller sizes of shards, so that no individual user can kind of take over the whole system. So that's another nice property that using a scalable system provides over a monolithic system, which you may be familiar with if you're coming to this talk from a traditional database space. Okay, so tablets. Tablet is the basic unit of work in a Vitess cluster. I did mention you can use any MySQL server flavor. You can also use what we call an unmanaged tablet. And we will use part of that as part of our migration strategy, where you can say, Vitess, don't manage the active replication health monitoring and things like that. Just treat this as like a MySQL instance to route to. And this is useful as sort of like an entry point to be able to get into Vitess. But I would say most users are using the fully managed scenario where Vitess is offering high availability and active monitoring of each of the tablets in the cluster. So tablet is comprised of MySQL and a VT tablet process. This is just a sidecar process that monitors and restarts the MySQL server if it needs to be able to do that. Okay, so architecture diagram, we have VT gates, we have tablets, and we have, as I said, optionally a load balancer. A couple of things to point out here that we'll get to later as well. By having these extra layers of the load balancer and the VT gate, you may find that although Vitess has very similar performance characteristics to MySQL, because it is MySQL, when it executes the query, it does add additional hops to be able to get to MySQL. So in terms of regressions, this is one thing you may notice, that you may see slightly higher latency if you move your application to Vitess. Okay, so let's talk about our plan. So we want to move from using MySQL to MySQL with Vitess on top. How would we go about achieving that? Well, my three sort of thought areas and sort of main focus would be on the queries that I execute. Do they work with Vitess? Does my application tolerate Vitess's performance characteristics that are a little bit different? We just mentioned that. And then the third one is, very cautiously in operations, no software is perfect. We have to have a plan to be able to back out if we can. And actually, I'll add to it, we have to have ability to sort of test it in a safe way in production without going, completely 100% Vitess on day one. So this is the scenario that we're going to talk about. And Vitess does have a very good answer for each of these points. So to start with testing our queries with Vitess, there is a program called vtexplain. So you could actually grab a copy of your queries and just run them with Vitess, but this is sort of a nicer way to be able to do it. So what I would do is I would start with my MySQL server. I would enable the slow query log, and I would set the long query time to 0 seconds. This captures all queries, not just slow queries. And I would probably try and get some sample that's representative of production load, so maybe half an hour or so. And then when I have this log file of all of my queries, obviously it's going to be very large. It could be several gigabytes. I want to be able to reduce that log file down to get just basically unique queries. So the prepared statement form of a query without the values in it. And this is what this program called PT Query Digest will do. It's part of the Percona toolkit. So what I often find when I do this is in a production application, there might be 50 unique queries that are used to access MySQL. There are definitely some scenarios where it might be more than that, particularly if you have some sort of query builder ORM that auto-generates queries for users. You might have thousands, but let's say in the typical case, we may have 50 queries that we end up with once we reduce them through this PT Query Digest program. Then what we want to do is we want to pipe the output of that PT Query Digest program, which will give us a smaller file of queries, through vtexplain. And there's some details to throw in here. If you're using just an uncharted Keyspace, I would expect that this would be fairly straightforward. You should find that all of the queries are working, particularly with Vitess 7 and above, as it has support for session context, something that was missing earlier. But if you use a sharded Keyspace, actually the way that you shard your tables, which you specify in something called a vSchema, can affect which queries are supported. So vtexplain can accept a vSchema and a schema to make sure that it validates with those settings that this list of queries is possible. So vtexplain in a nutshell. Here I say vtexplain with this schema, which is my MySQL DDL, and this vSchema, and with 2 shards, will this SQL query work? And then I will get some information to say, yes, here is how it works. So I'm not going to specifically cover the sharding in this talk, but I think it's an interesting segue to very briefly touch on how you choose to shard your database. Often you're going to be modeling it on how the data is accessed. So if you're a SaaS application, you may be sharding by the tenant to say that for this individual tenant, I want all of their data to kind of reside together in what we would, in database terms, say clustering, which is a bit of an ambiguous term. So I want to cluster the user data all together so that I'll get very efficient queries. How you do that, though, there are some variations where that might be a good idea or it might be a very bad idea. If you tend to have very large or lopsided distribution of tenants, so let's use the example of Slack, where individual Slacks could be very large in the individual tenants. It might actually be better to shard on the tenant's tenant, so the individual Slack channels rather than the Slack deployment. And I think the best way to get an answer for this is to join the Slack channel for Vitess and say, here's how I plan to shard. Do you have any experience? I will note, though, one of the interesting things about Vitess is it does make it very easy to be able to reshard if you've decided there's a better way to lay out your data, and that you can kind of change the scheme and reshard to a different way of laying out your data. The alternatives to using something like Vitess is you may actually change your application so that it manages the sharding. And if you do this, I think it's very hard to kind of change the scheme over time. Often, if you don't incorporate this into your design, that there could be some problem. So interesting segue, but let's flip back to our migration. So we validated that our queries work with vtexplain, and we get no errors. And it looks like we're ready to proceed forward. or almost. There might be some scenarios that are hard to test. Maybe you might find that you've tested today's queries and you've validated them, and there's something else that's in production. We have to make sure that we have that ability to back out. This is basically just the first level lint check to know that our Vitess migration is going to be successful. So I would say that I run this in dev, I run this in QA. I make sure that I catch the typical gotchas, as well as things that might be coming through in dev and production that we might not catch. We might not have got a very indicative sample of our slow query log file in production. So you might have some specific reports that run on the first day of the quarter that might not have been captured. And I think this is very hard to have 100% certainty. All of this is sort of building towards the confidence to make sure that we know that Vitess is likely going to be a good fit for our application. But you may find that just through many moving pieces that there will still be some queries that you might have to fix as you migrate. Okay, so let's go to the second part, which is to make sure that we can survive the added latency. Vitess requires at least one more network hop to go through that VT gate to go to MySQL. If we use the load balancer as well, which I said is a common deployment scenario in cloud native applications, you've got two more hops. So the scenario where this is going to hurt the most is if we're doing a lot of queries to load an individual web page. If we imagine that our application is a web app. So there's this pattern called N+1, it goes by many names, but that's the one that I call it, where you've got a while loop, and inside the loop, you're doing queries, repetitively accessing the individual values for this row that we're analyzing. So you've got a while loop on 100 rows, and then you've got 100 queries for each of those back to the database. I think that very often those queries, when they get to MySQL, they're basically free. They might take 0.1 or 0.01 of a millisecond to execute on MySQL. But I think to design a system, I use the back of the napkin math that it's about 1 to 2 milliseconds to get to MySQL and back. So if we can imagine that we've got 100 queries that is taking 100 milliseconds plus a little bit of small bit on top. Once we add 2 more network hops, we're looking at 300 to maybe more milliseconds for that while loop. And this might be sufficiently enough that it could actually impact your application. I tend to think that this impacts the badly designed applications the most. So maybe this is an opportunity to fix your app at the same time. Generally, you'll eliminate that querying in the while loop by sort of like batch retrieving it before you do the while loop, maybe with a big in clause in a query to MySQL. If you can't do that, let's pretend, for example, that you've got a while loop where the results of the previous query impact the next query. You may have to use some sort of parallelism to be able to reduce this latency, but latency is something that you should keep in mind in your evaluation or your validation of Vitess. It's not unique to Vitess by any stretch. If you're evaluating other distributed databases as well as Vitess, I think they're all going to suffer a very similar problem to this, in that they do have more components and more hops to be able to get to the data. Okay, and then the sort of third part of this story is that everything's looking good so far, but how do we do this in a safe way that makes sense for ops teams? And a good practice with deploying changes is that you should use a Canary. So if you can, just deploy to 5% of your application rather than 100%. This is generally fairly hard to do with stateful services, because they start modifying data. Often it's done with deploying new versions of your application. But as we observed when we looked at that architecture diagram, and I'll flip it back up in a second, a lot of Vitess is actually stateless. The state is stored in MySQL. So it is possible to deploy Vitess sort of like on the side and route some of your application through Vitess and the rest of it directly to MySQL to be able to do that validation. And if we have problems, we can just roll back to regular MySQL as required. So typically what I'm doing when I first start out with 5% is I'm operating Vitess and making sure that it reacts the way I expect it to. So is the CPU load acceptable? Maybe it's got logging. I make sure that it's not filling up disks through those log files. I look for errors in my application. I look for errors in both MySQL and Vitess logs. And then I start ramping up that load to eventually getting to 100%. So let's look at that on a diagram first. I'll throw up my architecture diagram again and say, these pieces in the middle, VTGate is stateless. The Topo server is your choice of etcd or Zookeeper. That's where the state is stored. So Vitess has managed to outsource and get out of that problem of storing state there. And then inside of the shards, it's using MySQL to be able to store that state. So this makes Vitess inherently having the building blocks to make a very scalable system. You can just add VT gates to add capacity, and you can scale by adding shards to add capacity in that stateful service as well. The VT gates don't even know really about each other. They just act completely independent. Okay, so let's talk about the Canary deployment on sort of an architecture diagram, a different perspective of that previous slide. So we have our application server on the left still, and then our day one deployment or our day zero deployment is that all of our applications were directly talking to MySQL. What we can do is we can have 5% of our application service or application speak to VTGate, which routes to VT Tablet, which uses an unmanaged or external MySQL. And this is where I would start out. So there's a few ways that you can do this. Maybe your application has a configuration file for the database server it speaks to. You may have to change whole servers to go to an individual Vitess or MySQL. Not many applications can roll the dice to say, 5% of connections go here. So that's kind of what I've done on this architecture diagram. If you have trouble doing this as well in your app, because you don't have many application servers, what you could also do is you could put a sidecar proxy on the application servers, and then you can basically pick 5% of connections and say they route through VTGate and the rest go to existing MySQL. And as I said, if it looks like it's healthy, I increase that from 5% to 20, 30%, and then eventually at 100%. If it looks like it's not, then I have a very easy way to be able to switch back to routing directly to MySQL. So our goal is to get to 100% because we won't be able to take advantage of Vitess until we get there, because we won't be able to shard these tables. If we did that, the existing applications that are connecting directly to MySQL are just going to be really confused. But we should find, or we should be able to validate in a production way that there's no added latency, there's no query errors, and then we basically just keep ramping things up till we get further along. Okay, so let's talk about the end of phase one is when we get to this magical goal of 100%, where we have all applications going to VTGate to see their version of MySQL. And then from there, what I would typically do is I would recommend that you move from using your existing MySQL server to using a MySQL server that's managed by Vitess. So we have now a tablet that's set up on my slide, where we have a MySQL server with that VT Tablet process. And then what I want to be able to do is move the data from my existing server live, so like an online migration from my existing server to Vitess. And Vitess actually supports the ability to copy this data over. It has a native workflow that it calls move tables. It's part of a feature called vReplication. Basically, it'll just follow the replication stream. So something called binary logging needs to be enabled on that existing MySQL server. It'll copy that data over to this new Vitess server. And then when it gets to 100%, you just have a very small blip of where those tables will be inaccessible while it catches up to the last part of replication. And then your VT gate knows that it has to connect to this set of VT tablets instead to be able to get the data for these tables. So that last operation, this is what we call a switch. So we have a move tables, and then we have a switch to be able to cut over it. And we like the term switch because it's like flicking a switch. That final operation should be very safe and not so destructive to make things completely live. Just a few requirements on the source to be able to do this. These are not actually the defaults in older versions of MySQL. They are the defaults in MySQL 8 and above, which is a little bit newer. I would say, most Vitess users are using MySQL 5.7 just for a little fact there, but many are migrating even from older versions, and it works pretty well. We in database terms use the terminology online to say that it's an online migration. It doesn't affect really your read operations or your write operations of the database. It just copies in the background while operations are still happening. So we end up to this phase where we've copied all of our data, and now it's in Vitess managed tablets. And then we're able to change the VT gate to say that now it should go to our natively managed Vitess to be able to get access to that data. From this point, we're able to do new development. Basically, we can start sharding our system. We can start adding new tablets if we need to be able to do that. We can manage this Vitess cluster with our VT-CTL GUI. We're completely in Vitess at this point. So if you were choosing to back out, the time to do this was when you were at that 5%, 50%. But the data is actually still in a MySQL format. So other than it being potentially sharded, if you do want to change, you do have that ability. Vitess doesn't really present you any lock-in. Okay. So our setup was that we migrated a legacy MySQL that was treated as one unsharded key space. In Vitess terminology, we'd say that that was a tablet server that was externally managed. And our new setup is that we have a Vitess tablet that's unsharded. We can still join queries between tablets in each key space, even when we move to sharded. It's recommended to keep updates contained within a single key space just in Vitess's design that it doesn't want you to do a two-phase commit to be able to do updates. So we didn't talk about our sharding design in this talk, but I did sort of allude to it. As you design things, often you're designing based on the tenant or something like that. If you want to learn more about Vitess, and particularly about this workflow, we have some very good user guides on the Vitess website. The one in particular that I'm basing a lot of this talk on is something called the Unmanaged Tablet Guide, which shows how to set up Vitess against a MySQL server that's not going to be managed by Vitess. And you can use this if you want to use Vitess against something like RDS, Aurora, Cloud SQL. And with that, let's open for questions. So, Sugu and I will be on the line. Thank you very much for joining us today, and please ask away.
All right. There are a few questions that we answered interactively. Maybe we can read out the answers of one of them. Let's see. We could talk about the I'm looking for a good one to answer since we are very short on time.
I think the minimum number of components one is a good one. What's the minimum number of components inside Vitess?
Yeah, all right. You answered it, so
I'll let you answer it again. Line if you want.
It's a quiz question. So we have VT Tablet, VT Gates, and VTCTLD. Those are the three main components needed for running a Vitess cluster. You can actually serve queries without a VTCTLD. To serve queries, you need only the VT-gate component and the VT tablet component. There's the other one, which is actually a very good question. That was about we implemented a Kubernetes topo server, but we deprecated Helm after that, and we did not port that implementation to the operator. It's something that we just didn't think about. But it is less important about which topo server you choose, because the whole idea of the operator is that it's autopilot. It should just run by itself. So you shouldn't have to worry about what it does underneath to store the topo. But if there are use cases where there is strong reason where somebody would want to use the Kubernetes itself as a topo server, it's something that we can add support for. But this is the first time I'm hearing this question, and that's also one of the reasons why we never thought about it, because the operator works so well right now as it stands. Do you want to take on the proxy SQL one as the last question?
Sure. So there was a question about how does VTGate compare to proxy SQL? And my answer was, I actually think that proxy SQL probably does better in performance. But the second part to that is how much will it matter? And actually both will add latency. And I think I'm generally more concerned about latency in a migration path. And it should be equal there. You may need to run more VT gates versus proxy SQLs, but because it's stateless, it's fairly easy to be able to do that.
Yeah. And Vitess is obviously a more comprehensive solution. So if you don't need all the features of Vitess, I would actually send you towards proxy SQL because it's more lightweight.
Awesome. I think we're at time. I don't know if our moderator is going to jump in and kick us out. But thank you for coming.
Yeah, thank you.
You would have seen a reminder pop up on screen. Please see us at office hours. I think it's starting in about 20 minutes time.